Welcome. I'm going to explain one vulnerability in the code I walked through in the last video. If you haven't seen that, definitely take a look at that video and play around with the code by yourself first. There are links to both in the video notes below. To recap, we saw some server-side JavaScript that lets a user view their private profile, lets anyone view any user's public profile, and lets any user cause a reset link to be sent. The code manipulates bags of properties. Instead of defining classes for concepts like user, profile, request, and password reset link, and then calling methods on those, it uses plain old JavaScript objects as collections of properties. Remember, to win, violate security properties by passing primitives to process.json. You can call process.json multiple times. If that wasn't clear, maybe pause and go give it another shot. If you found a vulnerability that requires only one call, or a different one than I outline here, I'd love to hear from you in the comments. It's possible to do this. Leak a reset link to a source other than the email of record for that account. First, I request a reset link. So I call process.json, and I'm passing in a string of JSON. The type of request is password reset. And I'm going to request it for the only other user in our user database, B678. And you can see it says sent a password reset link to user B678, and it comes back with the user ID. Then I request the public profile in a way that generates an error. So again, I call process.json. And the type is now public. Any user can request any other user's public profile. And here's how I generate an error. I throw in this spurious real name property. And I get an error in the log. You may have to scroll right to see all of it. Here's URL, youforgot.example.com, and then a nonce, a long unguessable string. And it's this nonce, which knowing this nonce allows me to maybe hijack Bob's account. Remember, the goal was to get the reset link to a source other than Bob's email. Historically, server logs have been less carefully protected than databases. This is a bit of a blind spot security-wise. It is often far easier for an attacker to read log files than a database or secrets in a server's memory. For more information, see the link in the notes to Carnegie Mellon's Software Engineering Institute, which says, logging is essential for debugging incident response and collecting forensic evidence. Nevertheless, logging sensitive data raises many concerns, including the privacy of the stakeholders, etc. Unfortunately, violations of this rule are common. So why does this attack work? Here's get password reset link. Why is the reset link part of the public profile? That's because of a quirk of how object.assign work. The first argument is the output. In this case, get user record of request. The second and subsequent arguments are copied into that first argument. This call to object.assign bundles inputs to an email template. Maybe the author forgot to type curly brackets, comma. Elsewhere they do, but it's an easy mistake to make and the kind of thing that a tired code reviewer might miss. Since the user record is cached in memory, the same value is used by the second call to process.json. The first call allocated a password reset link, which due to an easily overlooked bug got attached to a long-lived object. The second call included a real name field. Get public profile double checks that real name is not linked. If real name in result. This is normally a great practice. But then object.assign combines the public profile and the request, ostensibly to make sure that the client gets appropriate display preferences. The sanity check throws, which bubbles up to process.json, letting me get the user record into the log. This logging string dumps a lot of information. It's not triggered in the normal course of events. Maybe it was left on in production code by mistake. The end result is that I took 2 actions that require no authorization and managed to leak something that might allow me to hijack an arbitrary account due to a bug that is easy to miss. This is a contrived example, but hopefully it convinces you that this bags of properties approach has risks. First, it makes it far too easy to mix trusted properties with untrusted properties. In this case, real name is normally just a property on a user object, but I put it on the request object, triggering a code path that is probably not well tested, the if real name and result path. That code path is normally an excellent thing to have. It would prevent a leak of real name. Another risk is that sensitive properties are no different from insensitive properties in the way they're represented in the runtime. If the user had to write a toString method for user data, they might have chosen to stringify display name, but not reset link. The third risk is that it's not obvious what gets mutated. If all changes happen via calls to this.property equals inside setter methods, then you probably won't get a reset link property on user data by accident. One way to address this problem is to not use bags of properties. That's a fine design decision, but in large systems, some parts use this approach. Even in static languages, template systems tend to take hash maps with string keys, and configuration objects are often bags of properties. And there are reasons for this. This sample is less than 100 lines of code, but does a lot. A class-based approach would probably require several times that. Another way to deal with this problem is to treat sensitive properties differently. JavaScript symbols are a great way to do this. JSON.stringify ignores properties whose keys are symbols, so using a symbol for the reset link URL and for real name would improve this code. I'm going to argue later that we need a consistent way to represent sensitive and privileged values. I'll go into that in detail later. Next though, a third security puzzler. Thanks for watching!